question 17 right here as well. Okay, take a look at it. You obviously answered all those questions. Notice your parallel lines are given to you. And in this situation, we are working with A to B equal to X. Now we don't have values of the angles. The angles are expressed in terms of X. So we're getting very close to the riders now. Okay, so we want to start by giving reasons why C1 should be X and why C2 should also be X. So let's write those reasons down quickly. It's 17.11. We can write C1 is equal to X. We can be convinced that it is equal to X because we are noticing how this one, look at it. We have the parallel lines here, and there it forms a Z. I hope you're noticing that one. So this one and that one are alternating angles. So that's why we said C1 is equal to X. So those are alternating angles. And it is CD, which is parallel to OA. Okay, that's the reason we need it. It's alternating. So this is X. That's our reason. And now we also have to explain why C2 is equal to X. So 17.12, I'm going to have to just mention this one statement first. OC is equal to OA. That's the radii of the circle. So this side and that side definitely equal. They're both radii. From here to there is the radius of the circle. From here to there, it's also the radius of the circle. So these two are equal. So in this situation, I can easily say C2 is equal to A2, which is X. So I can put X here as well. So here is the reason. We were just expected to write the reason, but of course I have to explain where it's coming from. So C2 will be X because these are angles opposite equal sides, like this. So that is why this one will be equal to X. All right, now let's go to these ones where we have to now express these angles in terms of X. We have to find them, but again, it's only going to be in terms of X. For example, now we are being asked for A1. Here it is. Now, if you are looking, look at BC. BC is the diameter of the circle. We were told O is the center in the actual question. So here, BC is the diameter. It's subtending A1 and A2. So these two here will definitely just give us 90 degrees. So let's write that statement first and reason. And that is angles in a semicircle. Good. So if this one is what we need right now, and we know that this is already X, it was given to be X right there, so we can easily see how A1 is going to be 90 minus X, like that. So that's A1. Let's keep moving. So it's 17.22 now. We want to calculate O1. But from where O1 is, it's quite difficult to tell. Or maybe not, because O1 can be seen as an angle at center. So I am going to rather say, if I come from AD, that's the angle at center right there, that's O1. The same AD is subtending something at the circumference, and you can see it's X. So in this situation, it wasn't very easy to see, but hey, look again. AD is subtending O1 at the circumference, and this rather at the center, and AD is subtending C1 at the circumference. So I can write that down quickly and say O1 is equal to 2 times C1. So its angle at center is 2 times angle at circumference. Well, there are many ways of doing this. One could have calculated D first. From at a place where D is, you can see since OC and OE are equal, you could call this one 2x. It will be equal to these two. And of course, D is alternating to O1. You could have used that one. It's not a problem. There are many reasons we can use to calculate one thing. So 2 times C1 is also 2x. You are going to get 2x anyway by either doing it this way or calculating D first and then noticing how O1 is equal to D. So whichever method you used, I have no problem with it, as long as you express it in terms of x. Right, then we want to calculate O2 now. O2, after we did this one, I think O2 will become easy because again, you can go to AB and go at center, and the same AB subtends C2. So I can really write that one. Okay, so I can find my O2 to be equal to 2x as well. But again, you don't want to limit yourself. Yeah, this same O2 can be seen as an exterior angle of triangle ACO. So you can say O2 is equal to A2 plus C2, that is exterior angle of a triangle, is equal to sum of opposite interior angles. You could have done that one as well. It works. So I'm sure you have those ones. And then lastly, there is that 17.3 of ours. We want to find the value of x that will make A, B, or E. In case you cannot see it, AB is this one, O, E, a cyclic quadrilateral. At this point, we cannot call it a cyclic quadrilateral. These two are not touching the circumference, but again, one property of a cyclic quad is that opposite angles should be supplementary. It means they should add up to 180. So in this situation, if you want to make A, B, or E a cyclic quadrilateral, we have to ensure that opposite sides are add up to 180. Let's not forget that we calculated this one to be 2x. So what I want to bring to your attention is that if I use these ones, I could have used these ones, but hey, there is nothing on E2, then I'll have to go and first of all calculate E2 and all those things. Or maybe exterior angle, but at this point it's wise to use what you already have. So for a cyclic quad, we know how A1 plus A2, which is angle A there, plus this angle, I'm going to call it O1 plus O2, it should be equal to 180. This will be opposite angles of a cyclic quad. Reasoning here is becoming a problem since it's not a cyclic quad. So for this to be a cyclic quad, this should add up to 180. So I am going to just write this one to be 90 degrees because we know it's 90. And this is 2x and that one is 2x. So I believe you're noticing how 4x is going to be equal to 90 degrees, and of course dividing that one by 4 should be simple, and that will be 22.5. So the value of x that will make this one a cyclic quad will be 22.5. So I'm going to just say opposite angles should be supplementary. It's very difficult to write a Euclidean geometry question without a reason. Okay, so this is what we've got for question 17. I hope you got everything right. Thank you very much. Now we are moving on to riders.